Looking at cranial nerve number 8, which is the vestibulocochlear nerve. If you can see, even from the name, this nerve has got two branches. You have got the vestibular division and the cochlear division. So again, when you look at the brain stem from an anterior view, you are going to have the midbrain on top. You have got the pons and then the medulla oblongata here down. So you can see the way cranial nerves come out. You need to understand this, right? So you have got cranial nerve number 3 coming out bit on from the midbrain. Now remember from our anatomy, cranial nerve 1 and 2 comes from the forebrain, 3 and 4 from the midbrain, 5, 6, 7, 8 comes from the pons, 9, 10, 11, 12 comes from the medulla oblongata. So, okay, let's start with cranial nerve number 1. Cranial nerve number 1, that's the optic nerve. It's this one here, this one, that's going like this, connecting here on what we call the optic chiasm. This is where some fibers, remember this nerve is for seeing, some fibers from the other side will cross to the other side, while some fibers will still remain on the one side. So they go like this. Some fibers will go like this, some fibers will cross. And then also the other side, some fibers will cross, some fibers will remain on the same side. And so you need to understand when there's a lesion on one point. So that's cranial nerve number 1. Cranial nerve number 2, this is the one here, the olfactory nerve. Actually, olfactory is one, right? You have got one nose. The olfactory nerve is the one. And then you have got the optic, which is cranial nerve number 2 for seeing. Cranial nerve number 3, that's the oculomotor. You can see that's the one that comes out here. Cranial nerve number 4 is the only cranial nerve that comes from the behind of the brain. So it's actually this one that you can see. It's coming from the back and then it comes to the front. This comes small one that you can see. Cranial nerve number 5 is found on the side of the pons. And remember, it has got two divisions. This is a trigeminal. It has got the lateral root, which is large. This branch, can you see this is the lateral, which is large? Then you have got this kind of small one, which is the medial. That is the, remember, lateral, large. And then you have got now the sensory, which is a small. So this gamma one here is sensory, SS. The sensory is small and it is a medial. This one, which is large, is the motor division. When you come to, so that's cranial nerve number 5. Cranial nerve number 6 comes out from the junction between the pons and the medulla oblongata. Just here, the beginning. And then you start following them. Follow this same junction. From 5, you go to 6. Okay? Sorry, from 6, you go to 7. So 7 is just, you can see these ones that I've circled. There are actually 3 nerves there. Now, not really 3, but 2. Okay, but the way cranial nerve number 7 is that it has got two branches. You have got this branch which is medial, and then you have got this branch which we call the nervus intermedius. We call it the nervus intermedius because it is between the first branch and the second nerve, which is cranial nerve number 8. And then from there you are going to be going down cranial nerve number 9, and then number 10 is down, number 11 is down. Now number 12 is not going to be in line with 7, 8, 9, 10, 11, but it's going to be in front. It's found here. So we call this structure here as a pyramid. And then this one behind is called the olives. So this space behind, in front of the olives, we call it the post-olivary fissure. And then you have got the space, this space behind the olives, we call it a pre-olivary fissure. So when you look at cranial nerve number 12, it comes from, actually pre is in front. So this is the pre. So cranial nerve number 12 comes from the pre-olivary fissure. while the other cranial nerves are coming from the post-olivary fascia. It's important for you to understand the arrangement here because the diagram can come for you to be able to label the cranial nerves. So now we are talking this region where you find this cranial nerve number 7, 8, 9. We call it the pontomedullary junction or cerebello-pontine angle. Okay, it's important for you to understand. So cranial nerve 8, 7 emerges from the ventral surface of the brainstem at the pontomedullary sulcus. We don't normally include 9, but mostly talk about 7 and 8. They emerge together on the pontomedullary sulcus or the cerebello-pontine angle. Very important there. So you imagine if there is an injury. So as we said, cranial nerve number 8 is a spatial sensory afferent nerve. Afferent means it carries sensations towards the central nervous system, and this sensation is for hearing and balance. So there are two spatial sensations: hearing and balance. So the vestibular part, because it is vestibulocochlear, the vestibular is involved in balance. It conveys impulses associated with body posture, balance, and coordination. For you to know that, okay, my head is facing up, my head is now facing down, and such is because of this division. The cochlea is the one that is associated with the hearing. And remember, these guys will leave the ventral surface of the brainstem through the pontomedullary sulcus. Why do we call it pontomedullary? It's between the pons and the medulla. It's also known as the cerebello-pontine angle because you are going to have the cerebellum. Okay, this structure that you can see behind is known as the cerebellum, the little brain. Cerebello-pontine. This is the pons. So this angle is between the pons and the cerebellum. So cerebello, not cerebro, cerebello-pontine angle, also known as pontomedullary sulcus. So what happens is that this cranial nerve is going to image lateral to the facial nerve. We already saw the arrangement, right? And it will run laterally in posterior cranial fossa and it will enter the internal acoustic meatus. Remember when we discussed cranial nerve number 7, it also entered the internal acoustic meatus. So normally when cranial nerve number 7 is affected, the nerve that is involved in picking up sensations of the face, what happens is that also balance and hearing might be affected because these nerves normally move together, especially if the injury is happening on that part where they move together. When you look at this cranial nerve, it will carry the vestibular pathway and the auditory pathway. So if you are hearing, what happens? So the auditory pathway is mouth synaptic pathway. Okay, meaning that you are going to be able to get different sensations and then converge them together for you to listen well. Mouth synaptic. So you are having a lot of nerves that are joining at one point for you to hear. And there are several locations between medulla and the thalamus where axons, my synapse, and not all the fibers behave the same manner. Because you know you have got different types of sounds, and so for you to be able to pick up the different sound sensations with different frequencies, of course, the actual interpretation is going to be happening in the brain. So representation of cochlea is bilateral at all levels above cochlear nucleus. So the cochlear nucleus you are not really able to identify here because the diagram is a bit or small. So, but we'll discuss that a bit. Let me show you how these structures are. So you have got two parts, remember. When you come to the ear, what I'm telling you here is neuroscience, but you can apply it also in head and neck. So if you understand it now, it means that when you do the neuroscience part, it will be way easier. Hope you can see this stomach structure that I'm drawing. Okay, let me start it like this. So when you come to this structure, you are going to see structures that run like this. Hope you can see. Okay, I hope they are clear enough. I'm trying to make it them as proper as I can. Okay, something like this. And then now I can draw the pinna of the ear, a structure something like that. And then we are going to have a nice common structure here. And then we are going to have two more small structures, one like that, another one like that, and then another one like that. So when you look at the ear has got three parts. We have got what we call the external ear. Okay, the external ear. The external ear, the main parts that it has, you have got the pinna, and then you have got this structure which we call the ear canal, external auditory canal, right? And then you are also going to have what we call the middle ear. The middle ear has got too many structures. You have got what we call the tympanic membrane, or the eardrum, this one here. Okay. And then you have got bony ossicles. For the bony ossicles, you have got three small bones. You have got the malleus, the incus, and the stapes. And these guys are connected. You can see the malleus attaches direct to the eardrum or the tympanic membrane, right? It attaches direct there. And then the malleus is connected to the incus, which is connected to the stapes. The stapes is connected to the cochlea. So this is structure that you can see in green. We call it the inner ear, the entire of it. So that's the inner ear. So the inner ear is made up of too many parts. You have got this entire part, this part here. We call that as a vestibular apparatus. Okay, vestibular apparatus. Why do we call it vestibular apparatus? Because it's involved in balance. Please take note is the vestibular apparatus. And then this structure that looks like a snail, which goes round, we call this as a cochlea. It is involved in hearing. Now, the vestibular apparatus itself is made up of three many parts. You have got these three structures, these ones, these ones. We call these as the semicircular canals. Semicircular canals. And then we have got this part here, which we call the utricle. It's a dilatation. And then we have got this part here, which we call the circle. Okay. So when you look at the semicircular canals, they are oriented in such a way that they'll carry the three planes. So if you are nodding your head, you have got what we call the lateral semicircular canal, and then you have got the anterior semicircular canal, and then you have got the superior semicircular canal. And what these semicircular canals do is that when you are moving your head, let's say if you are nodding, or if you turn to the sides, right? Or like you are trying to round your head. Let's say for example, you have got someone on your side. You want to look at them, you turn your head. Or let's say for example, something went in your ear. So you want to let your ear to touch your shoulder. So how do you do it? You move your head, okay, so that your ear can touch your shoulder. So all these movements are going to be taken by the semicircular canals. And so We call that as a angular acceleration. So semicircular canals are responsible for noticing angular acceleration. Okay. Now when it comes to the utricles and the circuits, these guys are involved in picking up what we call static equilibrium. Static equilibrium. Let's say, for example, when you are moving forward, but you are not moving your head, you are just moving forward. So for the body to sense that you are moving forward, or let's say you are jumping up and down, but you are not moving your head, you just jump straight up. For your body to pick that you are jumping straight, it's a function of the circuits and the utricles. I don't want to talk about much details because that is going to be neurophysiology. I can talk about the mechanism of how that happens. So take note, angular acceleration and the linear static is also known as linear. So linear acceleration is via the utricles and the circuits. These two guys inside, they actually have what we call the mercules, and the mercules are the organs that will be able to pick up this the static equilibrium. Okay, and then at the end of each semicircular canal, there is this dilatation. We call this as the ampulla. So the ampulla contains special receptors that will be able to pick up this angular acceleration. Inside the cochlea, you are going to have canals. You are actually going to have a membrane there which will go all the way together like that. And then you are going to end up with the three spaces because you are going to have two membranes which are going to be separating these. So I've got a membrane on top, you have got a membrane there, and then a membrane here. So you have got what we call the vestibular opening here, and then you have got also the media. It's on the middle, this opening again, and then you have got this one which is down. Let me see if my I've got a nice picture that can show that. Okay, not really for here. Let me see down. Okay, so if we take a cross section, can you see these openings? You have got this one, and this one. This is a cross section of what I was drawing. So the one on top we call it the scala vestibuli, the one on the middle we call it the scala media, the one down we call it the scala tympani. Okay, so what happens is that in the scala media, this one, you are going to have a special structure which we call the organ of Corti. So the organ of Corti is so special in such a way that it's the one that contains the receptors for hearing. That's very important for you to know. At least I've tried to describe, right, what happens. And so what happens is this. For the vestibular division or the vestibulocochlear nerve, you are going to have a nerve coming first from the semicircular canals, okay, like that. This one is going to form a ganglion and then continue like that. And then you are going to also have a ganglion coming from these two structures picking up static equilibrium, and then it will come and connect. So these together will form one nerve which we call the vestibular nerve. And then from hearing also you are going to have fibers coming like that converging to form a ganglion which we call the cochlear nerve. And then now these are going to connect to form now what we call the vestibulocochlear nerve. So altogether cranial nerve number 8 has got a 3 ganglia, right? The one coming from the cochlear ganglia, and then you have got two that are for balance. So you have got the static equilibrium and the linear equilibrium. I hope that makes sense. Is there any question? Do we get the sense there? Okay. So that was about, so the auditory pathway, the first nerve is coming from what we call the organ of Cott, which is within the scalar media. The scalar media is also known as the cochlear duct. And actually, in physiology, neurophysiology, it's going to be important for you to understand that the scalar vestibuli and the scalar tympani contains what we call perilymph. This is the same as extracellular fluid, ECF. And you know that in ECF we have got a lot of potassium, right? And then scalar media has got endolymph, and endolymph is the same as ICF. Okay, actually the ICF is more as potassium, the ECF has got sodium, because remember P's are more inside the cell like proteins. So this is what happens. This is what you need to know, but that is going to be again application for neuroanatomy and neurophysiology. So the first nerve is going to come out because the nerves that I told you that you are going to have a ganglia first coming from the semicircular canals, and then another ganglia coming from the utricles and the circles, and then another ganglia coming from the cochlea. This guy will actually form a structure which goes like that. It looks spiral before it can continue moving. So that's why it is known as a spiral ganglion. Okay, spiral ganglion, which is within the cochlea, the organ of hearing. So the central processes are then going to end up going to terminate in the dorsal and ventral cochlear nucleus. So the cochlear nucleus is found in the inferior cerebellar peduncle. Cerebellar peduncle, if you have got, this is your midbrain, this is your pons, and this is your medulla oblongata. Behind you have got the cerebellum that can relate to brain. Cerebellum is also involved in balance. So connecting the midbrain to the cerebellum, we have got the superior cerebellar peduncle, the pons to the cerebellum, that's the cerebellar peduncle, and then the medulla oblongata to the cerebellum, that's the inferior cerebellar peduncle. So the dorsal and ventral cochlear nucleus are found in the inferior cerebellar peduncle. They actually lie close to this inferior cerebellar peduncle, the cochlear nucleus. So when you have got these structures like this, you have formed your spiral ganglion. It is going to go and then it will synapse, okay? Because these nerves are first coming from the head, right? They are going to go and connect to what we call a second order neuron. So you have got a connection of neurons. When you're talking about the sensory system, you have got a neuron that moves from the organ you are talking about to the central nervous system. That's a first order neuron. From this central nervous system, you are going to have now the neuron going now to the cerebrum, okay, the main brain for interpretation. That's called the second order neuron. So that's what is happening there. So when you look at the auditory pathway, this is the one that is here a bit of complex. And for head and neck, really, there's not much for you to master here. But from the when you have got your your cochlear division of cranial nerve number 8 going to the cochlear nucleus, second order neurons are now going to move from the cochlear nucleus, which is found. Remember what I've just said on top, right? The nerve will first move from first order neuron has moved from the cochlea, which is in the ear, okay, up to the cochlear nucleus. From the cochlear nucleus, that's where we're having now the second order neuron going to the cerebrum. So that's what is happening. So what happens is the second order neurons are going to ascend into the pons. So they'll go to the pons, and then most of the fibers will cross the midline in what is called the trapezoid body. Okay, the trapezoid body, and will terminate in the nucleus of the trapezoid body, or on the contralateral, the other side, in the superior olivary nucleus. So let's say you can see this structure here. That's a cochlear nucleus. So you have got first some fibers that are going to cross. So when they cross, they are going to go to the trapezoid body. And these are the structures here that you can see. Okay, these are these fibers that are crossing. They are going in what we call the trapezoid body. And then when they go crossing to the other side, some of the fibers are going to end up just here in the nucleus of the trapezoid body. Others are going to end up going to the superior olivary nucleus there. And then from the superior olivary nucleus, some fibers can still come back to the other side in what we call the lateral lemniscus. Okay, while some other fibers can still go the other side. They can even go to what we call the nucleus or the lateral lemniscus. And then these fibers will ascend up and go to the inferior colliculi. Remember, inferior colliculi is related to hearing. Superior colliculus is involved in sight. And then from there, the fibers can now go. You have got the branches of the inferior colliculus. They are going to the medial geniculate nucleus. So please take note that the medial geniculate nucleus is related to what? To hearing. The lateral is related to sight. Lateral geniculate nucleus. We discussed it when we were discussing cranial nerve number 2. Okay, again, I'll not stress much there because you understand this in neuroscience. But take note that these fibers are going to end up going to the primary auditory cortex so that you can be able to hear the sound. Now, the brain is divided into what we call Brodmann areas. So, specifically, the auditory cortex, if you want sound to be interpreted, you have got Brodmann area 41 and 42. That's where sound is interpreted. And it's located in the dorsal surface of the superior temporal gyrus. That's known as the Hiss's gyrus. Again, that's going to be important for neuroscience. Okay. Some fibers are actually going to end up going to some other areas, for example, area 22. Area 22 is known as the Wernicke's area. The Wernicke's area is important in understanding sound. Okay, so if someone has got a problem with the Wernicke's area, area 22, it means that they can't understand sound. You also have got what we call the Broca's area. The Broca's area is motor, it helps you to speak. So if there is a problem with Broca's area and Wernicke's is okay, Wernicke means you can understand, but Broca you can't speak. So you are able to understand, but you can't speak. For example, most of the people that are mute, they'll just, if you talk to them, they'll be understand, but they'll just be saying, ooh, ooh. That's because there's a problem with Broca's area. But others, they can have an intact Broca's area, but there is a distraction to the Wernicke's area, so they can speak well, but they can't understand what you're saying. So you say, how are you? They say, actually, yesterday I went to church. It was so nice. So they are not responding to the question that you're asking because the area that helps them in understanding is not working. That's the Wernicke's area. So all these areas are important for you to be able to work, okay, and for you to be able to pick up sound. So that is the auditory pathway to be just simple. We'll talk about the details and the nitty-gritties when it comes to neurosciences. Again, the vestibular pathway, I've already described it. The only thing that I want you to understand for now is that the fibers coming, you can see you have got the vestibular ganglion, okay, which is there. And this is made up, these are actually supposed to be two ganglions. Why? You have got one coming from the sulcus and the utricus, one from the semicircular canals. And those are the ones that will end up forming one cranial nerve. And you can see some fibers will actually go to the cerebellum because vestibular apparatus is involved in balance. The cerebellum is also involved in balance. So those are going through what we call the inferior cerebellar peduncle, right? Going to the cerebellum. Some fibers, besides going to the cerebellum, some of them will go to the inferior vestibular nucleus, lateral vestibular nucleus, medial vestibular nucleus, superior vestibular nucleus. Again, the details of that we'll discuss neurosciences. For here, no. Okay. So about the vestibular pathway, also discuss that in neurosciences. Just something on the clinic that you need to understand. When there's lesion on the vestibulocochlear nerve, it will produce deafness. Remember, this is involved in hearing. So there's going to be disturb. So deafness specifically is disturbance to the cochlea. While if there's disturbance to the vestibular nerve, vestibular is involved in balance. So we're going to be hearing like ringing sensations. We call that tinnitus. Like you are hearing bells, a ringing sensation in your ear. You can also have vertigo. Vertigo is a feeling as though you are moving in circles. Okay? Think of if you've been in the merry-go-round like that. So I hate that sensation. That's vertigo. You can also have dizziness, nausea, nystagmus. Nystagmus is where, let's say for example, you are turning in like you are spinning, right? You are spinning, and then now they tell you, okay, stand. I want you to look at one thing specifically. What will happen is that your eye will fail to face and look that thing exactly. Why? Your eye will start moving, rotating. They go left, right, left, right, like that. Why are they doing that? It's because you can't be balanced just there, and then it has to first settle because your body is still in motion. That's nystagmus. There can also be loss of balance and ataxia. Ataxia is where someone is walking and then by the intent, as though someone is drunk, right? They are walking as so drunk. So these are features of distraction to the vestibular nerve. Acoustic neuroma is a benign tumor. A benign tumor is a tumor that is not malignant. Like it's a cancer, but it can't spread. That's the meaning of benign. So when you look at cancers or tumors, you have got benign tumors and malignant tumors. So a benign one can't spread. So acoustic just means hearing. Neuroma, neuro is referring to nerve. When you look at names that end in oma, it means that those are benign tumors. So this is a benign tumor of eighth cranial nerve that leads compression of nerve, leading to attacks of dizziness and profound deafness and ataxia. But the thing is that because cranial nerve number 8 and 7 moves together, so expect that if there is acoustic neuroma, you can have also symptoms of a problem of cranial nerve number 7. Okay. So you can have complete deafness of the affected ear only caused by damage to the middle ear, cochlear, or auditory nerve. So the only thing that can cause complete deafness is when there is distraction to to the middle ear. Remember, the middle ear is either the eardrum or those stomach bones, or to the cochlea itself, or to the auditory nerve. Okay, not anything beyond that. Not after the cochlear nucleus that is found in the bones. There are actually two tests that you can do to confirm if someone has got some hearing problems or not. We have got what we call the Weber's test and what we call the Rhine's test. So for this test, you just want to identify which side of the ear has got a problem. So you actually use a tuning fork. You are going to get a tuning fork, you hit it on a surface so that it starts vibrating, and then you put it on the forehead. Okay, you put it on the forehead. What happens is that you should hear the sound equally on the left ear and on the right ear. So if you can only hear the sound in one ear, it means that there is a sound lateralization, like you are taking the sound to only one lateral side, and it means that there is a problem in the other ear. And then for the Rhine's test, you are going to again get a tuning fork, you hit it on a surface, and then you get a tuning fork you put on your bone prominences, Like for example, I've got the mastoid process that is just down your ear, and then you'll be hearing sound. And then after a vibration, sorry, after the tuning fork stops vibrating, what you do is now you bring it near to your ear. You still hear the vibration. Okay, you remove it from the bone and then you bring it near to the ear. So this test is just to tell you that sound travels more in hair than in bone. But if there's the rise test is not what I've said, it means that there's actually a problem with hair and bone conduction. You do this also in clinical skills. It will be a practical that you are going to do in clinical skills. I'll show you some pictures later on. I didn't include them here. So that is it about the vestibulocochlear nerve.